Hello, my name is Dixon, and I'm with Carve Systems, and we're talking today about cheating in esports, how to cheat at virtual cycling using USB hacks. So, yeah, I'm really talking about bicycling, and you might not think about bicycles as having a lot of technology in them, or maybe all the technologies in the manufacturing materials. But over the past few years, electronics and software have been creeping into the components that high-end professional cyclists and the really competitive amateurs use. And wherever there's software, we know that there can be hacks. And that's cool. But I was kind of interested, and Mike Zussman is my boss over there is also interested to say, well, what can we do more to cheat? Because the cheating is really kind of, I'll talk about it as the most fun part of competitive cycling, I think. And just so I don't disappoint anybody, we're not talking about these esports. So there's no great Fortnite hints, no League of Legends hints, and those are cool. What we're talking about is something a little bit different. We're talking about the sweaty esports. And so these are people who compete in esports where the performance of their avatar is driven by their physical performance in the real world. They're actually dropping sweat and doing work to win in these competitions or just for exercise. But there's something cool about this. Unlike other esports, virtual cycling is part of the greater world of cycling. So just a little backstory for you. There's a group called the Union Cycliste Internationale. And the UCI is the federation that governs all cycling competitions, whether it's road biking or mountain biking or BMX, or there's some very odd artistic bicycle competitions that I never knew about that people do. The UCI sets all the rules for those. And so they work with the International Olympic Committee. The International Olympic Committee last year had a meeting that said, we want to start including esports in the Olympic program somehow. So everybody came to this forum, including all of the, I'll call them the video game people, like Fortnite, League of Legends, all that stuff, and these weird little cycling people on the side. So the International Olympic Committee had one of these big meetings, lots of food and wine and drinks for a week or something. But out of this, they came out saying, yes, we really do want to include esports in future Olympic programs, but there's a catch. And their catch was that they thought that esports that involve, killing didn't really sit with the vibe of the Olympic movement. They're not so much into that. And so the virtual cycling people are really excited about this because they're looking at it going, I don't know, there's Wii bowling, and then there's us. And so virtual cycling is gonna, maybe rank on up there. And I'm excited about this because cyclists have the best cheaters. I mean, they're seriously the best. They're absolutely the best. I mean, Tom Brady should learn from these people. I had to get them in there. Sorry, Tom. So just a little history on here. So the Tour de France got started in 1903. Organized cycling as a competitive sport had only been going on since the mid-1890s. And this guy here, not actually mine, my buddy Hippolyte here, he was racing in the first Tour de France, really competitive, and he had to drop out because he had intestinal duress. But later investigations theorized that this was actually him. He received a spiked bottle of water from the other competitors, and this kind of stuff went on. The guy who made the Tour de France, a little bit of a sadist. In his view, the perfect Tour de France, which is a 21-day race, 2,200 miles, the perfect Tour de France would have only one finisher. Everybody else would drop out, die, or quit. And he never really reached that goal, thankfully. But the competitors, even in the early days, they would inject their muscles with strychnine, just to deaden them, so they could take more pain, more suffering, and make it up that hill. But don't worry about Hippolyte. Hippolyte learns really fast. He comes back the next year, and he put together this scheme where he put a cork in his mouth, had a rope, and the rope was connected to a car, and that car would tow him up the hills. And it would have worked, but Hippolyte finished just after the race officials got to the end of the course to set up for the finish, and Hippolyte comes flying in, and they disagree with that. This guy, Maurice Garin, he kind of like up the Keystone Cops level here. He had itching powder stuck in his rival's shorts. He sabotaged bikes of his rivals. He actually had a part of the course where he took a train to just skip past all these other riders and picked up from there, and then had all the supporters spread broken glass in front of them. Very creative. And then, you know, in the more modern era, this guy, Jean Robic, he would have this scheme where he'd ride to the top of the hills, and just before the descent, his support crew would hand him new water bottles. He'd stuff them in his bike, and these water bottles were filled with lead, just to make it go faster down the hill. But the funny thing about this is that at the time, this actually wasn't illegal. You could do this. He was fine. But in the modern era, cheating has continued and has this 100-year history. It's gotten more technical. In 2016, we had a rider that was, and not a competitive rider, just a rider, ejected from a race for actually having a motor in the seat post of the bike. And in 60 Minutes did a program all about this. It's actually quite fascinating if you want to go find that. And then there's this guy. If you know one cyclist, you probably know this guy, Lance Armstrong, famous/infamous for being a 7-time winner and cheater of the Tour de France. And he put together, not just, like, he didn't just dope himself, he had like an entire mob that was responsible for getting him the material, doping the teams. I mean, it was quite a production. But it wasn't just him. He won 7 years. There were 21 podium finishers of the Tour de France in those 7 years. And of those 21, 20 were later discovered to have been doping through either their own admissions, sanctions from investigations, or other erroneous or suspect test results. So 20 out of the 21. They actually didn't award those years to anybody, just like nobody won those years. They're all doping. So we started looking at virtual cycling, and we were like, nobody's going to cheat on this, because like it's a video game, right? But, you know, as people have started to have for-money competitions in virtual cycling, I found this noted internet expert who said things that this is such a big sport, you know, lots of money on the line, it'll sure to happen. So how does virtual cycling work? So it's a game put together with a couple of sensors. It's just like any other large multiplayer online game, but these sensors measure the athlete's real performance. There's another aspect to it that the rider sits on what's called a trainer. Let me see if I can get my video going here. So the rider sits on a trainer, and they take the wheel of their bike off, mount it on the trainer. The trainer does two things. It measures their power, and then it also offers resistance. And the resistance is what, you know, makes the work happen, right? Typically, the trainer also measures cadence, how quickly the pedals are turning over, and then they'll wear a heart rate monitor to measure that aspect of their performance. All of this feeds into the game. And from that, the games have a speed estimation model. It's based on a few things. It's really pretty simple. There's a terrain model for the course, right? When the course goes uphill, the game increases the resistance of the trainer, so you have to work harder. And of course, that elevation change slope that feeds into the speed estimation. Your power is an input to it. Two other things are controlled by the game player. There's the rider mass, you just type that in, and your height. Now, mass is pretty obvious. The lighter you are, given the same power, the faster you'll go, and the faster you'll go up hills, especially. Drafting, though, is what the height plays into. Drafting is not just like a little thing in cycling. It's like the thing. That is a big part of strategy and how riders and teams ride in competitions. And so they've emulated this in the game as well. And your height goes into that. And the games aren't really clear about how it works, but there's good evidence to show that if you're a shorter rider drafting behind a taller rider, then you're going to get a drafting boost from that. So the easy ways to cheat are just to make yourself lighter and shorter in the game. Just change that. And in fact, there is a Redditor that pulled together a bunch of data looking at how often people change their height or weight right before an online virtual cycling competition. And there's links to that on the website that you can go take a look at. So there's evidence that people are doing that as well. But you can't just use those to get maximum superpower. They're the bicycle police out there in the world of online cycling. The game that I used for this is something called Zwift. There's others out there, but Zwift is definitely the most popular. And Zwift published some e-racing guidelines, and written by lawyers, really kind of interesting though, talking about performance limits. So in Zwift, performance is measured in watts per kilogram. The idea being, if you're a taller, bigger, stronger person, then you have more muscle. And so your wattage output can increase. And it's watts per kilogram over a duration of time. So for example, if you exceed 5 watts per kilogram over a 20-minute period, you're going to get flagged for potentially a follow-up investigation. If you exceed 20 watts per kilogram for a 5-second period, like a sprinter might do at the finish of a race, first of all, you're like a superhuman. That's like amazing performance. But second of all, the Zwift bicycle police are going to come looking at you potentially. And we'll talk about potential ways you can cheat given this performance review board. So I chose to put together a hack so we could cheat at this game using the sensor network. And the sensors are an 802.15.4-ish protocol called ANT+. That's the RF link between the sensors and the USB dongle. There's optional encryption that can be turned on in ANT devices. Nobody turns that on, so that wasn't a problem. But we wanted to have a way to be able to influence these sensor readings directly. If I can control the sensors, then I can control the game. And so the easiest place to do this was the USB interface between the USB ANT dongle and the PC running the game. And so I built a tool for some commercial work that we were doing. And I wanted to retask this to something fun. And so we picked Zwift on this. And so this tool is called USBQ, and it's put together so you can explore and hack application level protocols that are flowing across USB buses. Now there's a lot of prior work in USB hacking. There's tons of stuff you can go read about. Just Google face dancer and you can find a couple of repositories, and there's a bunch of people who have contributed great tools for doing the kinds of USB explorations that you might want to do if your objective is to target the USB drivers or operating system interfaces of a USB host or peripheral. So they can do all sorts of interesting tricks with face dancer. You should definitely take a look at it if that's your objective. There's also tons of great links under this Hardware Village USB links page put together by Andrei Konlov. Go take a look and find that. But the first thing I'd recommend if you want to start hacking on USB is just use TCP dump and Wireshark. Really simple, always works. And on a Linux host, you can plug in a USB device, use TCP dump against a USB mon interface, and get captures of USB packets. USB is a networking protocol, which is kind of counterintuitive because you see serial in there, but Wireshark is great at looking at this. So when I was working on this commercial project doing this USB hacking, I knew about the face dancer code, and that was what I thought I was going to end up using. But I had one challenge in this project I was working on. It was a USB high-speed interface, so I couldn't use the face dancer board, which only supports USB low speed. There was some hardware out there, and I'll talk about that in a moment. But it was at the moment you couldn't just buy it. You had to solder it together, and honestly, my soldering skills and PCB assembly skills are pretty bad. So I knew that'd be a big waste of time. But I did find a toolkit put together by a man named Benoit Cameron of Airbus Sec Labs. Benoit built a pretty cool tool. He published a paper about it that's linked to on the site as well. And so it was a Python 2 user space and a loadable kernel module that could be installed on a Linux kernel running on any board. Now, the board has to have two things. It has to have a USB host interface and a USB device interface. The device interface is what re-exports that to the host. And so some boards have that, some don't, but the Beaglebone Black is a good, easy-to-find choice that does. But I had this idea because there's a few things I wanted the tool to do that it did. So I just decided, let's just do a little shorter project to rewrite the whole user space side of this. And, and that's what ended up being USBQ. So USBQ, like I said, the thing it's good at is for when you're not trying to attack the operating system or the drivers, but you want to be able to inspect and modify the application communications that go back and forth. And in fact, I didn't want to break the drivers, right? I need those to work. And so with a board like the Beaglebone Black, you can set it up, plug your USB device to one end of the board, plug the other USB interface into your host computer, and then install the loadable kernel module. You can start up the USBQ user space application, and then it'll receive packets over UDP when they come in from the device, process them however you wish, send them onto the host, and the reverse. So now there's just another tool in the toolkit out there for you to work with. But some things have changed on the face dancer side that are worth mentioning. For one, there's a new board out by Michael Osmond called the GreatFed 1. And that has higher speed USB interfaces on it. So that's a good board. You can pick them up now, just buy them. They're like $100. I've got one and I've just started fiddling with it. You can also use USBQ with a off-the-shelf piece of hardware like a Beaglebone Black that you might have. And I'll talk about how I used it in the application hacking. So this is USBQ. It's a command line application. It implements by itself just one command, MITN, man in the middle, and has a set of plugins that go with it. The plugins do various stages of packet manipulation as stuff flows back and forth. Let me walk you through that. USBQ is super simple. It's just got a main loop that goes on continuously. And in that loop, it grabs packets from the device, sends them through the tool, and then onto the host, grabs packets from the host, sends them to the device, and then has a tick to let plugins do work. For each packet processing stage, the orange boxes, it's a really simple set of hooks that are called. I'm using a plugin framework I'll talk about next, but you can provide your own hook implementations. So there's hooks for waiting for a packet, getting the packet, decoding it into a format that you want to work with, logging it, modifying the packet, so you can do whatever hack you want to do, encoding it for transmission, and then sending it out the door to the host of the device as is appropriate. And these, again, are all hooks, so you can use the existing behavior that USBQ has, or add your own capabilities. The plugin framework is built using a great toolkit in the Python world called Pluggy. Pluggy's super awesome. If you've worked with PyTest before, you use tons of Pluggy implemented hooks in there. But it gives a bunch of defined extension points that you can override or modify however you need. So, the basic tool just does USB, but if you want to do USB with an application level protocol like you did with Zwift, then you write plugins that sit on top of that. And there's basic plugins for doing things like getting and sending packets and decoding them to a SCAPI representation so that you can then manipulate the fields. And gives you some convenience features for development. Some of the convenience features that'll help you out, it'll always do a PCAP capture, so you can look at what happened on the wire after you're done. But most useful to me was that I coded an ability to be able to reload plugins on the fly. Lots of times you'll be hacking things that take a while to boot up, or there's a complex synchronization process, something that like you don't want to reboot the board every time. And in the case of Zwift, the game takes like about 3-4 minutes to start up, so that's pretty slow. And so I can start up the game, have it running, and then load the plugins that introduce the hacks, change stuff, unload them, reload them again, and do all of that through a pretty convenient interface. There's IPython console support too, so you can just reach in there and manipulate packets on the fly. So USBQ is available now at usbq.org. It's an MIT licensed component, piece of software I should say. I've got some planned work that I want to do with it. First of all, it's dependent now on this loadable kernel module, which is GPL v2 licensed. That module's good, but it's not part of the mainline kernel. And so I'd like to work on USBQ so that it can use a native feature called USBIP that's in most Linux kernels. USBIP support is so that the kernel can reach out and use a remote USB device over a TCP connection. It's really pretty cool. And that's half of the problem that I need. We need to also implement another mainline kernel feature to be able to then create the emulated USB device on the other interface of the board. So that's something that right now the kernel can't do. I'd like to see that improved. And we've got one working example in an out-of-kernel module thanks to Bit 1. The great Bit 1, as I mentioned, looks like a really great board. I'm going to start figuring out and see if I can integrate that with USBQ as well. It looks pretty straightforward. And then on the more important side, I want to start building other types of protocols that will ride on top of USB, so that no matter what your hacking project is, you've got a man-in-the-middle tool that knows how to work with that packet format just by installing a new Python module. But back to the cycling part, and more importantly, the cheating part. So, like I said, USBQ is just a generic man-in-the-middle tool, but I wrote another plugin that sits on top of it that I like to call Elance, the Lead Automatic Esports Network Cheating Enhancement. For my man Lance. So there's a lot of great features that you get with Elance. And how many of you guys ride Zwift? Anybody here? All right? Okay, you're going to be winners tomorrow. It's going to be awesome. Because you get two modes. You get EPO mode. EPO mode is great. This is probably the one you want to start with because like Mike Zussman over there, Mike is like a real bicycle rider. I ride bikes like kids ride bikes. Like I just like riding down the hills fast and goofing around, and I just like to go places. Mike is serious. Mike actually trains. And so if I'm ever going to have a chance to beat Mike on Zwift, I need his EPO mode thing. And what it does is it lets you sustain that performance without having to work nearly as hard. So you can dial up how much performance boost do you want. Would 20% help you beat Mike? I probably need 50. And it also makes the world flat. So when your avatar is riding uphill, instead of pedaling getting harder, you just stay the same. Only Mike has to work. And that's a good thing. And so EPO mode is what you want. It's also realistic, because you do have to work a little bit, but for some people, this might not be good. And so for you, there's slacker mode. It's too important to risk sweating. This is the mode for you. So slacker mode gives you the ability to use an Xbox controller to run the game. And it's really kind of stupid because it takes a game and turns it into a one-dimensional game. You just squeeze the trigger. At that point, what do you do? But you do you. So slacker mode does this for you, and I've got some new features that I'm working on. I want to do cruise control on there. That's really easy. I actually built that when I erased the code. Sorry. But then most importantly, because the bike police are out there in the Zwift world, I want to work on a mode that will use other riders' real-world performance from a website called Strava. people all over the world publish rides they do on Strava, and will have their power data on there. And you can get course elevation data. So I'm going to use that and say, okay, when all these other riders ride this course, this is their maximum power. I just want like that plus one. And so then I think I can pull this off. So the Elance plugins for USBQ are put together really because it looked fun and is a good like example plugin for how to work with a pretty straightforward protocol like you find on Zwift. And so USBQ gives you the blue parts at the bottom. The basic host device interfaces, the ability to pass the packets back and forth. But the orange parts on top are what are in Elance. And if you're working on a new protocol, something that's not in there now, you'd want to write new hooks, and you can use Elance as a model for that. And so the plugins that I have in Elance will decode these ANT plus protocol packets. ANT plus, you might not have heard, you probably haven't heard of it before, but it's a predecessor to Bluetooth Low Energy, and it's something that's used primarily in sporting and fitness equipment. Like if you have, it's owned by Garmin nowadays. So if you have a Garmin watch, it probably supports ANT+, and you can hook it up to an ANT+ heart rate monitor or a foot cadence meter, and so when you go out and do your run, you get all this data that streams off of there. And it's a predecessor to Bluetooth Low Energy, but has very low-level security support, pretty much none at all. You can set a network key, and from that it derives an AES key. But since it's really hard to type in a network key onto a piece of fitness equipment, I don't think anybody does that. So it's always in the clear. They just do a pairing step. But the ANT+ protocol is really well documented. At the website, edope.bike, that's the site for this talk, it'll link you over to find the ANT+ payload definitions. And you can just register as a developer, get those payload definitions. And in there, there's a field that has that indicates for power, just defines what's the instantaneous power that this rider is mashing the pedals with. And that's what we were hacking in this example. So when you put it all together, you have USBQ in the middle, and it's doing three things really well. It's modifying power as it streams past from the sensors to the game. It's tweaking your heart rate and your cadence to keep stuff normal looking. And then it's also controlling the grade or the resistance that the trainer sets. And all of this, you guys can go do yourself if you want to. So let's do the demo. So this is Elance running in the top left on top of USBQ. And then I'm going to get, it fires up here and connects with the kernel module. And now it's set up so that my device, which I've plugged in, all the packets are running through USBQ, and I'm starting up Zwift. Like I said, Zwift goes a little slow starting up. But the first step that you go through any time is setting up the sensors. This box over here on the left, that's just a rendition of my Xbox controller. The horizontal band at the top, that's the right trigger on there. So you can see that, that's my throttle input. And we're connecting over ANT+ to the three sensors I have for this experiment here. And then we'll get off riding shortly. Now, you may not be familiar with like how many watts you make when you ride a bicycle. Like, you know, if you're a kid and you ride a bicycle and you're working really hard, you might be making 100 watts or something. That's kind of what you feel like. When I ride a bicycle, like 187 watts, that's a pretty good pace. But now I don't have to be limited by my own physical limitations and disinterest in training, because I can hack stuff. 500 watts is crazy power. For me, that's nutty. Mike probably does that like every day riding at home from work. But, like, like Homer Simpson said, there's the right way, the wrong way, and the max power way. And so I want to see, like, we've got this big 16-bit field. Can we really crank it up? So I took the limits off, and screw the bike police. Let's get this thing going. And so when you crank it up to Zwift, this is crazy power right here. And you get achievements, and then you get this one, the 1.21 gigawatts award. But Zwift has some senses in there. The game, like, you go too hard, too fast in certain sections of the course, and they ding you. And they're like, no, something's broken, cheater. Why don't you fix that? And something you may not have seen in there, you get a little dunce cap when you do that. So when your sensors go all wonky like that, your avatar gets a dunce cap, this little orange triangle, and every rider can see that out there. So if you want to pull off this trick with your friends, you got to make sure you set your power limits so you don't get the dunce cap. Okay, that's important. But then, you know, we're back to like, this is really about, can we cheat? Could we like really cheat in a competitive event? And we've definitely like proven, if you just want to cheat yourself out of a workout and, you know, drink a beer with your bike on cruise control, yeah, you can do that. That's not a problem. You're just going to have to use sensible limits so you don't get the dunce cap. But cheating in an online race is going to be a little bit harder for you. In Zwift, every day, there's just dozens and dozens of rides that they have. And there's a website where every rider who enrolls in a ride, their performance is recorded on there. So they're winners, right? And like anything where there's a ranking, some people are really super competitive about it. And one point I want to make is that in this research, I took care never to actually compete and finish in a race. Because even if, you know, I'm not taking this seriously, but other people do, and it's really important to them, and I don't want to, like, you know, screw somebody who's like actually trying to be a good cyclist. Most people on Zwift are just there for the workout. They're having fun. But I do think it's very possible to take a mediocre rider like me and stretch him into somebody that's more competitive. But you're going to have to be careful about it. First of all, you're going to have multiple accounts. Not a big challenge. But you're going to have multiple accounts so you can probe the limits of you know, getting the dunce cap, and also in what this in any, you know, any time the bike police are out there, you want to figure out, well, what are the things that clue them off. You're also going to have to, with your real competitor account, build an in real life track record riding that bicycle. This is because in the Zwift e-racing rules, this is part of what they look at. They want your Strava profile to be open. They want to see that you've done a lot of real-world riding out there. Now, luckily, you can fake all that too. You know, you just upload data to Strava, and it's like, yeah, you did that ride. So you've got, you know, more hacking to do to pull that off. But you can, just like with drug testing, the Zwift e-racing rules say that in competitive events, that anybody who finishes on the podium, top 3 finishers, and 2 other competitors will be subject to the ominous-sounding performance review board. The performance review board has a couple of things that they talk about that they might do. One of them is they might require you to weigh in on video. So, you know, get busy hacking your scales so that when you step on them, you actually measure lower. And make some funny little rulers that are, you know, not quite a foot, so you come out short. I think you guys can do this. But there's a catch we'll get to on the next slide. The other thing is that they'll want you to possibly submit, at their request, like a second power source recording. So you're going to have to get another power meter, put it on your bike, maybe on your crank, do a ride, and then download that data file with no authentication, modify it, and upload it to them. So I don't see a big barrier in doing that, because we like hacking things. It's not a big deal. But then there's a requirement that they might ask you, you know, maybe if they see me present at DEF CON, to go to a third-party verification lab where you have to hop on a real bicycle and ride it in front of people. So by this point, if you've already committed to doing all of this stuff, you might as well bribe, lie, do whatever you need to do to get a third-party test lab to sign off and give you say, yeah, he actually can generate 2,000 watts for half an hour. I don't know how his muscles didn't melt. So get to work on that. That's an important part of the ruse. But then not every competition in Zwift is going to be online. Next year, the UCI is going to have a world championship of what they call e-bike racing. And this is virtual cycling, not to be confused with bikes with batteries. So, like, they're going to have a world champion of virtual cycling. That's a big deal. And that competition and the prior 4 money competitions that have happened in the Zwift world have all been live competitions. Things where you show up and, you know, maybe unlike the Fortnite championship where that kid won $3 million and there's not like thousands of people, it's like 10 people watching, but you got to do it live. And that's hard. And because you're going to have to weigh in, and you're not going to be able to bring your funky scale or your short ruler. And so you probably don't want to lie about that. And you're going to have to figure out if you're going to use this hack, some way to get your exploit actually in the chain. And our friends at the NSA, when they're not busy writing software reverse engineering tools, have been building funky USB cables for years. Mike Lossman also built one, and it's really fascinating to look at it. And just this week, another presenter had a doctored iPhone cable that was like a dead ringer. So you can definitely make these cables. The hard part, though, is going to be getting them onto your bike. So, I don't know, hire a magician or somebody with like sleight of hand skills. You know, you're going to have to figure that out. Maybe do it the NSA way, just interdict all the cables, replace all of them with doctored cables, so then you can control your bike and everybody else's. I think that'll work. But there's other ways too that we're working on, and hopefully be simpler, that will require physical access. Just not quite done with them yet. But I also want to mention that, you know, I found out just this week that there's another researcher out there who took a different path to cheating in Zwift. His name is Keith Wakeham, and I'll have his video linked to off of ego.bike. And so Keith took the path of saying, forget buying hardware or man-in-the-middle stuff, I'm just going to build completely fake sensors. And so he has a complete sensor emulator board that just does away with that. He can control everything directly. Now that's an interesting approach, and it definitely worked. But one of the things is, like, as the bike police get smarter, you know, they'll maybe take more steps in software to verify that the hardware is actually the expected hardware. And so that might involve probing for behaviors which are not commonly used by the game, but can be used to at least try to authenticate the hardware. And so if those features aren't emulated, your cheat might be caught. So, you know, 2 different ways, and there's going to be some more, definitely. So wrapping up, if you want to cheat yourself out of a workout, go ahead. It's totally possible. But this shows, like, the general challenges that we see in industries when they try to take sensors and software that haven't been designed for secure applications and then shift it to a place where people, like, care about status and money and fame. Like, what could go wrong? We've seen this movie before. And this situation with Zwift is just one of these things that's happening. And it's not just Zwift. All of the cycling, all of the virtual cycling applications are going to have the same kinds of difficulties because they all depend on the same kinds of sensors. So it's just not a good foundation for security. And the second part is that, well, the third of the bullets here, is that there's a lot more electronics and software creeping into cycling. So if those organizations that govern cycling are not already looking at security as part of, you know, software and electronic security as part of their competitive integrity measures, they really need to start doing that, because we really like hacking things, and when people have lots of money on the line, they'll do weird things, you know, when it can make a difference for them. So I hope you enjoyed this little insight into the crazy world of cyclists, their cheats, and I really recommend go find something that's got USB and go start hacking with it. If you want to find all the slides, all the links to the software, I've got a bunch of references you can read as well, so you can go find all these articles and also find all the technical details that you need. All of that's at edope.bike. Thank you very much.
Subscribe, like, and share if you enjoyed this video or learned something, and comment below what you found interesting.